How to check whether two lists are circularly identical in Python. For instance, I have lists. They seem to be different, but if it is supposed that the start and the end are connected, then they are circularly identical. The problem is, each list which I have has a length of 55 and contains only 3 ones and 52 zeros in it. Without circular condition, there are 26,235, 55 choose 3, lists. However, if the condition circular exists, there are a huge number of circularly identical lists. Currently I check circularly identity by following. This function requires 55 cyclic shift operations at the worst case. And there are 26,235 lists to be compared with each other. In short, I need 55 times 26,235, 26,235 to 1. 2 equals 18,926,847,225 computations. It's about nearly 20 giga. Is there any good way to do it with less computations? Or any data types that supports circular?
First off, this can be done in ON in terms of the length of the list. You can notice that if you will duplicate your list 2 times, 1, 2, 3, will be 1, 2, 3, 1, 2, 3, then your new list will definitely hold all possible cyclic lists. So all you need is to check whether the list you are searching is inside a 2 times of your starting list. In Python you can achieve this in the following way, assuming that the lengths are the same. Some explanation about my one-liner. List 2 will combine a list with itself, map str, 1, 2, convert all numbers to string and .join will convert array, 1, 2, 111, into a string 1 to 111. As pointed by some people in the comments, one-liner can potentially give some false positives, so to cover all the possible edge cases. P.S.1 When speaking about time complexity, it is worth noticing that ON will be achieved if substring can be found in ON time. It is not always so and depends on the implementation in your language, although potentially it can be done in linear time KMP for example. P.S.2 for people who are afraid strings operation and due to this fact think that the answer is not good. What important is complexity and speed. This algorithm potentially runs in ON time and ON space, which makes it much better than anything in ON squared domain. To see this by yourself, you can run a small benchmark, creates a random list, pops the first element and appends it to the end, thus creating a cyclic list. You are free to do your own manipulations. .3 seconds on my machine. Not really long. Now try to compare this with ON squared solutions. While it is comparing it, you can travel from us to Australia, most probably by a cruise ship.
Not knowledgeable enough in Python to answer this in your requested language, but in C++, given the parameters of your question, I'd convert the zeros and ones to bits and push them onto the least significant bits of an int64_t. This will allow you to compare all 55 bits in one fell swoop, one clock. Wickedly fast, and the whole thing will fit in on chip caches, 209,880 bytes. Hardware support for shifting all 55 list members right simultaneously is available only in the CPU's registers. The same goes for comparing all 55 members simultaneously. This allows for a one-for-one mapping of the problem to a software solution. And using the SIM/256-bit registers, up to 256 members if needed, as a result the code is immediately obvious to the reader. You might be able to implement this in Python, I just don't know it well enough to know if that's possible or what the performance might be. After sleeping on it, a few things became obvious, and all for the better. 1. It's so easy to spin the circularly linked list using bits that Dolly's very clever trick isn't necessary. Inside a 64-bit register, standard bit shifting will accomplish the rotation very simply, and in an attempt to make this all more Python-friendly, by using arithmetic instead of bit hops. 2. Bit shifting can be accomplished easily using divide by 2. 3. Checking the end of the list for 0 or 1 can be easily done by modulo 2. 4. Moving a 0 to the head of the list from the tail can be done by dividing by 2. This because if the 0 were actually moved it would make the 55th bit false, which it already is by doing absolutely nothing. 5. Moving a 1 to the head of the list from the tail can be done by dividing by 2 and adding 18,398,509,481,984, which is the value created by marking the 55th bit true and all the rest false. 6. If a comparison of the anchor and composed at win64_t is true after any given rotation, break and return true. I would convert the entire array of lists into an array of a win64_ts right up front to avoid having to do the conversion repeatedly. After spending a few hours trying to optimize the code, studying the assembly language, I was able to shave 20% off the runtime. I should add that the OS and MSVC compiler got updated midday yesterday as well. For whatever reason /s, the quality of the code the C compiler produced improved dramatically after the update, November 15, 2014. Runtime is now 70 clocks, 17 nanoseconds to compose and compare an anchor ring with all 55 turns of a test ring, and NXN of all rings against all others is done in 12.5 seconds. This code is so tight all but 4 registers are sitting around doing nothing 99% of the time. The assembly language matches the C code almost line for line. Very easy to read and understand. A great assembly project if someone were teaching themselves that. Hardware is Haswell i7, MSVC 64-bit, full optimizations.
Reading between the lines, it sounds as though you're trying to enumerate one representative of each circular equivalence class of strings with 3 ones and 52 zeros. Let's switch from a dense representation to a sparse one, set of 3 numbers in range 55. In this representation, the circular shift of S by K is given by the comprehension set I plus K, %55 for I in S. The lexicographic minimum representative in a class always contains the position 0. Given a set of the form 0, I, J, with 0 is lower than I is lower than J, the other candidates for minimum in the class are 0, J, I, 55, I, 0, 55, J, 55 plus I, J. Hence, we need I, J is lower than or equal to min J, I, 55, J, 55 plus I, J, for the original to be minimum. Here's some enumeration code.
Repeat the first array, then use the Z algorithm, O n time, to find the second array inside the first. Note, you don't have to physically copy the first array. You can just wrap around during matching. The nice thing about the Z algorithm is that it's very simple compared to KMP, BM, etc. However, if you're feeling ambitious, you could do string matching in linear time and constant space, str, for example, does this. Implementing it would be more painful, though.